A coal plant, a nuclear plant, a hydro dam, and a wind farm all look completely different from the outside. One burns fuel, one splits atoms, one holds back a river, one catches the wind. But deep inside, most of them are doing the same surprisingly simple thing: spinning a machine. That machine is the electric generator. And it is one of the most important machines on Earth, because almost everything in modern life depends on it. Your lights, your fridge, your Wi-Fi, your phone charger, hospitals, trains, factories, data centers, even the screen you're watching right now. But here's the strange part: most electricity is not made the way many people imagine. It is not poured out of coal, it is not stored inside nuclear fuel, and it is not magically created by a power station. In most power plants, electricity begins with motion. The real trick is turning something, anything, into a spinning force. In a coal or gas power plant, fuel is burned to create heat. That heat boils water into high-pressure steam. The steam rushes through curved metal blades and spins a turbine. In a nuclear power plant, the process looks more futuristic, but the idea is still similar. Nuclear reactions create heat. That heat makes steam. The steam spins a turbine. In a hydroelectric dam, there is no fire and no steam. Instead, falling water rushes through the turbine and spins it directly. In a wind farm, moving air turns the blades, and those blades spin a shaft connected to a generator. Different energy sources, same basic mission: make something rotate. Now the question is, how does spinning metal create electricity? Inside a generator, there are magnets and coils of wire. When a magnetic field moves past a wire, it pushes electrons inside that wire, and moving electrons are electricity. This is called electromagnetic induction. Here is the scientific trick. Inside the generator, a powerful magnet is rotated near tightly wound coils of copper wire, or in some designs, the coils rotate inside a magnetic field. As the magnetic field moves across the wire, it keeps changing direction and strength from the wire's point of view. That changing magnetic field pushes the electrons inside the copper back and forth. But here's the part that sounds confusing. If the electricity is coming from coils of copper wire, why doesn't the wire run out of electricity? Because the coil is not a battery. It is not storing electricity inside itself and slowly emptying. Copper already contains huge numbers of electrons, but those electrons are not the fuel. They are more like the moving parts inside the system. The real energy is coming from the spinning turbine. As the turbine forces the magnet to keep rotating, the changing magnetic field keeps pushing electrons in the coil again and again. So as long as something keeps the turbine spinning, steam, falling water, wind, or gas pressure, the generator can keep converting that mechanical energy into electrical energy. And big power plants make huge amounts of electricity because the generator is built on a massive scale. The magnets are extremely powerful. The coils have many turns of copper wire. The rotor spins at a controlled high speed, and the whole machine is designed to handle enormous current. More magnetic strength, more coil turns, faster motion, and stronger mechanical force all increase the electrical output. A small hand crank generator uses the same principle, but your hand provides only a tiny amount of energy. In a power plant, the turbine may be pushed by superheated steam or thousands of tons of falling water, so the generator receives a huge amount of mechanical power to convert. Also, big power plants usually do not send electricity straight to your house at the final voltage. The generator may produce electricity thousands of volts, but then transformers increase that voltage much higher for long-distance transmission. Raising the voltage helps move large amounts of power through power lines more efficiently. So the giant numbers you associate with power plants come from two things working together: the generator creating massive electrical power, and transformers changing the voltage so that power can travel across the grid. That means a generator is almost like an electric motor in reverse. A motor uses electricity to create motion. A generator uses motion to create electricity. And this is why the turbine generator is everywhere. A power plant is basically a giant chain of energy conversion. Chemical energy: if fuel becomes heat, heat becomes steam pressure. Steam pressure becomes spinning motion becomes electricity. Even nuclear power, one of the most advanced energy technologies we have, still often ends with the same old school move: make steam, spin a turbine, turn a generator. That is the hidden joke of modern electricity. We have built massive power stations, complex control rooms, cooling towers, dams, and offshore wind farms, all to do one ancient-looking thing better and faster: spin a wheel. But not all electricity comes from spinning. Solar panels are the big exception. They do not spin a turbine. They use semiconductor materials to turn sunlight directly into electrical energy. That is one reason solar power feels so different from traditional power plants. No steam, no rotating turbine, no giant shaft. Just sunlight hitting a material designed to release electrons. To learn more about how solar power works, watch the full video, linked in the pop-up banner and in the description. But for most of the electricity that has powered the modern world, the generator has been the final machine in the chain. And keeping that machine stable is harder than it looks. The generator has to spin at the right speed. The electricity has to match the grid. If demand suddenly rises, maybe millions of people switch on air conditioners, power stations have to respond. If too much electricity is produced, that is also a problem. The grid is not just a giant battery sitting there waiting. It has to be balanced second by second. That is why control rooms watch electricity supply and demand constantly. Behind the simple act of turning on a light switch, there may be turbines speeding up, valves opening, water gates adjusting, or generators being synchronized with the grid. So the next time you plug in your phone, do not just imagine electricity coming from a wall socket somewhere, maybe hundreds of miles away. Steam might be screaming through turbine blades. Water might be falling through a dam. Wind might be turning a rotor. A giant magnetic field might be slicing past copper coils thousands of times per minute. And all of that motion becomes the silent tower flowing into your home. The machine that makes almost all electricity is not flashy. Most people never see it, but without it, the modern world goes dark. If you have enjoyed this video about electricity generation, make sure you subscribe to Knowledge Hub for more hidden technology insight, everyday things, and as always, stay curious.